It's rarely shown, but in reality, the vast majority of deep sky is almost everywhere. In every direction, riddled with holes, filled with voids that look more or less like this. Except that since we love light, when we look at the cosmos on a large scale, we usually point our telescopes toward things to observe, where matter has accumulated in large quantities. And so, to show images like this one, where we can see gigantic gatherings of billions of stars spread across dozens of galaxies facing us. But these images are often misleading because they don't easily show the distances separating these galaxies from each other, and they make us lose sight of the truly monstrous distances that separate us from all of this. So, in an image like this, a large part of the galaxies we see are actually located in the background, within galaxy clusters that are several 100 million light-years away from the objects in the foreground. To put it another way, as beautiful as these images are, like magnifying glasses focusing on the details of an elephant, they only give us a partial glimpse of the entire universe. They don't tell us how all these galaxies are distributed in 3 dimensions in space. Just a few decades ago, we thought that galaxies were generally uniformly distributed throughout the cosmos. Before discovering that, under the influence of gravity, they gradually clustered over time into groups, clusters, and superclusters, forming on ever larger scales a 3-dimensional picture in which strands of galaxies meet, intertwine, and pile up, taking the shape of a vast cosmic web woven from immense interconnected filaments. And these filaments, which can stretch for tens or even hundreds of light-years in length, together form a cosmic tapestry that marks out regions rich in matter and others that are almost completely devoid of it. In a sense, they wrap around vast regions of astonishing and immense cosmic voids. So, when we observe the distribution of matter on these ever larger scales, the universe appears to us as an immense foam, a collection of galactic filaments, lines of higher density that wrap, curl, and curve around dark regions, like so many bubbles of space-time, almost completely devoid of any matter. And it is there, in the depths of these gaping voids, these giant holes, that lies the heart of the subject we are now going to dive into. Here is one of the most striking images ever taken of the deep sky. Striking not because of what it shows, but because of what it does not show. You are currently looking at one of the largest voids in the known universe, the Boötes void, which encompasses a region about 300 million light-years in diameter, and in which, as you may have noticed, almost nothing seems to be present. Obviously, these vast empty regions are not completely devoid of all matter. Occasionally, you can even find galaxies there, though they are extremely sparse. Within the Boötes void, a total of about 60 galaxies have been identified, terribly isolated and far apart from each other, in a volume where, normally in the matter-rich regions of the universe, tens of thousands of galaxies would have been found. Thus, these 60 or so galaxies are spread out here in a volume nearly 2.5 times larger than that of the Virgo supercluster, which contains more than 10,000 galaxies. In fact, the Boötes void is so immensely empty that if our galaxy were at its center, we wouldn't have known that other galaxies exist in the universe until the middle of the last century. This spiral galaxy, observed here by the Hubble Space Telescope, is one of the most isolated that has been identified in the universe. There is no other galaxy around it for 100 million light-years. And that's in every direction. Imagine for a moment if our planet were within this galactic solitude. Here, space truly lives up to its name. Located about 700 million light-years away from us and 300 million light-years wide, the Great Boötes Void would almost seem like an interruption. And yet, this immense bubble, containing mostly emptiness and radiation, is just one among many others in space. Because these spheres filled with practically nothing are scattered throughout our entire observable universe. We have catalogued thousands of them, with sizes generally ranging from 30 to 300 million light-years in diameter, and they can be found everywhere, no matter which regions we look at. The great voids are an integral part of the immense cosmic tapestry. They are the spaces between the threads. In fact, if we consider the considerable volume of all these voids combined, we can say that they make up the vast majority of the volume of the universe. And it's strange to think that we are even right next to 2 of them in relatively close proximity. Because the local void, a region almost completely devoid of galaxies that stretches nearly 200 million light-years across, is located near our local galactic cluster, which, like a veil, follows its boundaries with its matter, partially covering it. Not far from there, on a cosmic scale, we also find the northern local supervoid, which, not only having a super name, is above all a region completely devoid of galactic clusters, spanning a staggering 340 million light-years in diameter. And we could go on listing voids for a long time. Everywhere we look, between what shines, there's a lot of that. Cosmic voids that, in reality, aren't really empty. Because even if we're tempted to picture these gigantic bubbles as spheres of almost nothingness, where matter seems desperately absent, they're not truly empty in the way we usually mean. To really understand why, let's take a moment to look at what we mean by the term void. Trust me and take a deep breath. And just like that, you've just inhaled several billion molecules. Air is odorless and transparent. Yet, even though we can't see it directly with our own eyes, there are a few hundred million billion atoms in every cubic meter of air around you at sea level. If you go up in altitude, the amount drops significantly. So, at 10 kilometers above our heads, it's divided by 4. Halfway to the moon, in what we might consider the vacuum of space, you can still find a few million atoms per cubic meter, which is still billions of times less than what we breathe. And if you go even farther, to the edge of the solar system, into the interstellar medium between the stars, that number drops to about 1,000 atoms per cubic meter. It is estimated that in the intergalactic medium, which as its name suggests separates galaxies, it can even drop to less than 10 atoms per cubic meter. A tiny amount, but not zero. Thus, inside these voids, there are extremely diluted atoms drifting in such large volumes that, when added up, they are actually very numerous. Just think, the intergalactic medium alone, with its mere 10 atoms of matter per cubic meter on average, would contain about half the mass of the universe. In other words, just because something doesn't emit light doesn't mean it's not important or doesn't have weight on the scale. From this point of view, these vast regions of space, which are called great voids in cosmology, are actually characterized by very low cosmic densities. And they are less areas where matter is conspicuous by its absence than gigantic volumes of space that are much less dense than the rest of the universe and at least 10 times less rich in galaxies per unit of volume than clusters are. And by broadening their definitions even further, these spaces filled to the brim with immense voids that aren't really voids at all are found everywhere, literally all around us. To illustrate this, consider that if we regard as empty any volume of space in which matter is significantly less present than it is on average elsewhere, then right now we are in the largest void in the known universe, the KBC void. A void 7 times larger than average, and which stretching over nearly 2 billion light-years encompasses our galaxy, as well as thousands of others around us. In other words, we exist in one of the least dense regions of space. We are, in a way, the inhabitants of a small town that's slightly more sparsely populated than the rest of the observable universe. With the only consequence being that we almost certainly have a deep night sky that's just a bit darker than it probably is on average elsewhere in the cosmos. And if you ask why we strive to study the extremely matter-poor regions of space, then remember that these empty regions are paradoxically packed with information, full of stories to tell. Because the presence of these absences is of great importance for advancing our knowledge and better understanding the history of our universe. On one hand, studying these regions, which give the cosmos its spongy appearance on large scales, could very well inform us about the initial conditions of our universe. Because these gaping holes most likely owe much of their origin to the conditions that prevailed in ancient times, and they probably all formed from irregularities on very small scales. Small density variations in the primordial universe. Small variations that, over time, would have been extraordinarily amplified by the expansion of the universe, eventually giving rise to these cosmic tapestries, all full of holes. And then, these voids could provide us with valuable information about the nature of the mysterious dark energy that might be behind the expansion of our universe and seems over time to make it accelerate. From this point of view, it's strange to think that it's also partly due to the presence of these bubbles, inflating like balloons expanding in all directions, that we owe the fact that these galaxies have, in some places, gathered together in groups, en grappe et en amas. Indeed, as the universe ages, the space inside these voids also increases in volume. And in doing so, like a snowplow, through its growth spurt, it pushes and packs some of the surrounding matter around its edges. In this case, to give birth to cosmic filaments, galactic walls, which by the negative shapes they take, reveal to us the boundaries of these gigantic bubbles of emptiness. The next time you look up at the sky to appreciate the visually filled parts of space, where the light of stars and galaxies shines, also remember not to completely overlook those regions right next to them. To focus your gaze and your interest a little on those spaces filled to the brim with emptiness, which also have a lot to tell us. And spare a thought for the galaxies that are isolated in the universe at the center of voids, like the Boötes void, which, with the accelerating expansion of space, see the distances separating them from the surrounding filaments becoming more and more insurmountable. These galaxies will be the first to find themselves separated by unfathomable distances from the rest of the universe. With the acceleration of expansion, to see the deep sky empty of all light.